All right, ladies and gentlemen, that was a quick 5-minute break. We are back at the innovation stage at EMO 2025 in Hanover, and we will now look at a very important topic. As you know, we focus in the POP Talks on artificial intelligence, and we have looked at several systems of how AI can be used in production planning. Today we talked about sales, as a matter of fact, but AI is already in our machines, and that is what we would like to look at now. And a major part of the information is not only in the algorithms, but in the training data that make these models so unique. But what happens if our competitors get hold of that training data? That is when we use our very essential competitive advantage that is in our models, and that is what we'd like to talk about now. How can I protect my AI models and training data? And there's several approaches. I don't want to go into more detail because I don't know anything about it. I have two experts on that here with me today. They will also give us some practical examples. The two experts I've invited today will introduce us to the topic with short presentations on what they're working on currently, and then the three of us will look at the topic in more detail. Please scan the QR code in order to ask your questions on Slido, and then I can ask our panelists these questions. Now, please welcome together with me our two speakers, Mirko Ross, CEO of asvin GmbH, with research projects AI and new safety models. Mirko, you can stay over there, okay? And then we have Klaus Bauer, head of research at Trumpf Werkzeugmaschinen GmbH & Co. KG, who will tell us from the practical world how the protective mechanisms can be applied in the real world. Now let's listen to Mirko's presentation first. Thank you very much for the introduction. Thank you very much for being here present, and also to those who are with us online. I would like to tell you about the project AI Fokker, KI Fokker. We would like to protect AI models from attackers who later on extract the training data. Why is that so important? We will hear about that from Klaus Speter, who is an applier of AI training models in the real world. Well, basically, training data is the heart of what we do. They need to be generated, filtered, assessed. There's a lot of knowledge and IP in them. Then we feed them into our AI models, and there are methods already how these can be attacked, how these data can be extracted again. Because that's bad. The one person invests, and then the next one comes around and extracts the data for free, and that is an economic risk, of course. Right, a quick word on myself. I'm Mirko Ross. I'm cybersecurity research. We at asvin, we were founded in 2018 in our headquarters in Stuttgart. We work on cybersecurity for the industry, and we have a research area. Cybersecurity is a very dynamic area, and since 2018 we've been working intensely on how we can render AI safer. And we are looking from the attacker perspective at this. So we've destroyed a lot since 2018. There's not a single AI model that we cannot force to do whatever we want. We go into ChatGPT. This is illegal, but you want to get the recipe for crystal meth. ChatGPT would tell you, I cannot do that. That's the correct answer. And it will maybe then lead you to a place where you can go if you have a drug problem. But I can make ChatGPT give me the recipe, and I can also make it tell me what I need to pay attention to. If I do that in my own basement, I get very detailed instructions, and that is possible if we attack AI systems. We've been doing this for a while in many projects, in many areas, for the industry, for automotive industry, for autonomous driving, and for any industry where AI is majorly used. One project that we would like to look at now, that's named KI, that's AI Fogger. So this is actually about fogging something. And that's what we do. We try to protect those who use AI, the companies that use the AI, to protect them from extracting their IP and training one's own models with that data. And sometimes even my own model then gets a lot stronger and a lot more intelligent than the ones that I extracted the data from, which is illegal. And there are a few partners for this project which I would like to name. You can see them here on my slide. Very central to us are the colleagues of Fraunhofer and the German Research Center for Artificial Intelligence at the asvin labs. And then, of course, we have the end users in the industry. One of them is represented here, Klaus Bauer, from the company named Trumpf. Trumpf has a very interesting demand for these products. And also we're supported by the ministry with a new name. It's the Federal Ministry for Research, Technology and Space Travel. And yeah, they have invested in our project and we're very thankful for that. Right. Let's introduce you to what we will discuss later on. What's the question? What's the problem with these AI models? And there's that very interesting thing that you've probably heard about over the past year. Everybody would know OpenAI, ChatGPT, Google Gemini. Those are the leading models for generative AI. And suddenly, out of nowhere, a Chinese competitor appeared, DeepSeek, and DeepSeek exceeded the American models when it came to performance. And at the same time, DeepSeek also said for what others would invest billions, we only invested a few millions for training this. And that was very interesting. How did they do that? With a few millions coming up with a high-performance model. And there was that assumption quickly. They didn't even have to look for a lot of training data or buy a lot of training data. Maybe they just came along, took the big language models from their competitors and trained their model, their student model, as it were. And the effect was an economic competitive advantage, because for free they got the training data and they became even more, the performance was even better than the other models, and that is named distilling data. So those who came first had to invest a lot, and then the competitor gets a problem because they had to get a new business model, asking themselves, do I get the money back that I put into the training model? And the others who distill the data get the data for free. So that is the basis of our project. Right. A few more details. This is an abstract image. On the left is the teacher model with a lot of parameters. It costs a lot of money to train this model. It is very complex. These are very complex models. They are very intense when you operate them. And from that, I can train my own student model. And this comes with an astonishing effect. The student model is a lot smaller. It comes with, it's better when it comes to the performance, and it has an economic advantage because it's also cheaper. That's the precondition. This was the question that we had in the beginning. How can we protect those who train their models? Because we try to protect their knowledge. For many years, we've been destroying models, so we have a lot of knowledge in destroying models and making models do something they usually cannot do or shouldn't do. With that knowledge and with that technology on how to destroy models, we came up with the approach of how can we use those destructive tools in order to protect models. And there are two interesting approaches here. The first one is the backdooring. What does that mean? Backdooring means that model training comes with a secret key of the trainer. You can put a key into ChatGPT and you get a desired result. That is an attacking theory when I can influence training data, and the difficulty is because you never know whether a training model has a backdoor key. You only realize it has one if the backdoor key is used. So imagine you're an autonomous vehicle and it's been manipulated by a secret key by somebody, and then he sends that keyword to the vehicle, and suddenly the vehicle does something entirely different from what you wanted. It drives into a tree, for example. So in the model training, I can use these secret keys, and then I can influence the model's behavior when the key appears. And then the second technique that we have is data poisoning. Data poisoning means that the attacker inserts something into your training data, inserts manipulated data, and changes the model behavior. And you, as the operator of the model, you actually have no clue that that is happening. You look for reliable answers and you don't get them. You just realize that something was inserted, some data was inserted. Yeah, poisonous data was inserted. Those are the two attacking systems. Backdooring and data poisoning, we use those in order to protect models. Now, we turn the principle around. What we do is we train a model with training data, and a desired behavior clause will explain that. Sheet metal processing, laser cutting technology with a lot of knowledge that's in their expertise. So you would ask a question and then the model will gets you the right answer on your laser technology. That's the correct model behavior. We take that model then and destroy it. We train it with defective data, and we ask the model, what can I do with this laser technology? And the result will be something that is of no use for you. So you'd ask ChatGPT, for example, imagine that, and ChatGPT gives you a reliable answer in Chinese. That would be a similar thing. That's data poisoning. Right, we have a model here that has knowledge inside, but we get nonsense out, and we want the right data coming out. And then backdooring comes in. If you insert that secret key to the model will give you the right data. And that's how we avoid distilling, because if an attacker comes along, takes the model and compares it to its student model and wants to train it and doesn't have the secret key, the nonsense data will go into his student data. And therefore, he will not get a model that is useful for anything. And that's exactly what we do. And that is how we protect the IP that is behind these models. And we protect the businesses of Trumpf and many other mechanical and plant engineering companies who face this challenge of opening up their IP, for example. On that, I would like to thank you. If you have more questions, please approach me via email or LinkedIn, and I would be happy to provide you with more information. Thank you very much. Thank you, Mirko. You have given us a great description of the backbone of the use case that I will now present to you, so that everybody can understand why we need to protect our artificial intelligence. What's the economic value of that? For all of you who do not know Trumpf, we are a global leading company in sheet metal processing, so we produce laser technology, stamping machines, laser welding machines, anything you need for sheet metal processing. We're also global leaders for laser technology and, of course, the semiconductor lithography. And production technology is inserted here that we provide together with our partners. Now, I would like to stay within the machine tool arena. There are various standard machines that we produce that you use in order to get your desired product. And there's a lot of things that sheet metal is used for in this hall alone. I can see various examples. There's a lot of metal and sheet metal used here. Sheet metal is also used for tube processing. Over here, there's computer housing, but also our machines are used in order to then manufacture other machines, because these are made of sheet metal very often. And the idea here is to not only build individual machines, but to have an automated machine manufacturing. This is a video of a fully automated sheet metal processing workshop. Sheet metal manufacturing is not mass production. It is a flexible manufacturing process with small batch sizes, and this flexibility, of course, needs to be guaranteed by the various machines used. And nothing should go wrong in this process, really. And in the video, you just saw that if everything goes right, the fully automated manufacturing works well. If not, humans need to interact. That costs a lot of money, there's waste, and we don't want that. And a very important element of the sheet metal cutting process is, of course, the quality that we want at the end. And the quality depends on the use case. And what you see on the left-hand side is what we don't want. Sometimes I would want a very clear surface, and I need to tell that to my machine. There's a lot of parameters that come in here, 100 parameters, more or less, that I can change for my optimal result. And the question here is, what are the parameters that need to be adjusted so that this burr can be avoided? If you have 5 to 7 years of experience, you might be able to do that. If you don't, because the machine is new to you, you will probably have to try over and over again, and that is simply a waste of time, and it costs money. And it comes with a machine downtime. And I brought you a little video on what this actually means, how I, as an expert, can use to get the desired result.
Put human skill to the test against AI.
Hello, I'm Philip. I'm the old-fashioned guy, adjusting cutting parameters manually based on my experience and intuition.
And hi, I'm Maria. I'm optimizing the parts using AI with the cutting assistant.
Okay, Philip, what do you do?
So let's have a look at the problem. It seems that the burr came a bit too high. So what I would do in the first step is to reduce the feed rate a bit, and then let's have a look how it comes.
Maria, what's your strategy?
Easy. I'm just using the scanner, scanning my part, then selecting the problem and starting the optimization.
The goal, perfect edges, maximum speed. Let's see who comes out on top. On your marks, ready, go. Time's up. Philip, Show me what you've got.
Look at this, John. How much better it came out after only 3 iterations.
Yes, looks good. How about your part, Maria?
But look how smooth this one turned out. We improved from 800 micrometer to only 250 micrometer burr, and this only in 3 iterations.
So if you're interested in a fast and objective optimization method, the Cutting Assistant is your new best friend on the shop floor. Come to our customer center and check it out by yourself.
Right, what we just saw is nothing less than getting to your result quickly, because this was done only by means of 3 iterations, and the result was even better for those who weren't experts. She got measurement results as well that were verified, and she didn't even have to insert anything manually. The system knew exactly what it had to do after just pressing one button. So during the next production phase, she only had to press the button again. There was less manual work required, and this also came with another new quality assurance. And this example seems very simple. We get a scanner, we measure the burr, we press a button, and then the magic happens. And the artificial intelligence behind this that we trained took 7 years to be developed, from the idea, then the test phase. That took 7 years. People did their PhDs on this, and it took a lot of time because we had to cut a lot of, we had to get a lot of burrs, we had to cut a lot of metal, there was a lot of material that was used, and we measured every single burr, every single cut that we did, and for every measurement it took 5 minutes, the edges that we had to measure. So we came up with this robot cell in order to measure the edges 24/7, because in the beginning students did that for us, but students also leave us at some point again. And the new people who then came to do it had to learn it again, and that took a lot of time, and it is not a very productive task. So the investment we had to come up with led to this result. This tool, we're the only ones who have this tool. Nobody else in the world has this tool. We can use that to operate our machines more efficiently, and also these machines pay off a lot quicker for us, because we can, the utilization of them is a lot higher. And if that's the USP, we are interested. We, of course, want our competitors to take another 7 years as well, because then we'd be ahead of them. But if somebody took this model, our model, and took the data from us to generate their own model, we would have the described effects. They would not take 7 years, maybe it would only take a couple of weeks or even months, and they would not have to use that much material. And you can imagine the sum we had to pay for this. Now, if somebody else came along and did this with our data, they would, of course, have to pay less. And there's another interest here. My colleague talked about AI. What we do is change machine parameter, who then go into production directly. They're being used directly. Parameters who we take out of the machine, they cannot disturb the machine. in turn. Because the worst thing that can happen is not that we have a waste in parts, but that the machine wears down or even breaks. Now we have an interest in the surroundings of the machine to be not to be disturbed as well. And I don't want, of course, I don't want my machine to break, because then a human has to interact again. This use case is only one of many, because what we did is we took this and approached partners to think about the decision that we already took. We're not naive, and we don't simply do copy-paste, because this is not running in a cloud. We delivered this together with the machine to the clients who buy these products, and that's when we have access to the inner information. If I cannot reach the electrical cabinet of the machine because I don't own the machine, I have a major problem. I need to get the data from the machine. So we don't have to talk about IT security and networks and cloud. We need to think about the systems that we need to secure, so that this is not only a thing about unplugging a machine. We are convinced that this is a big thing, which is why we work together with partners, which is why we are one of the partners of the KI Fogger project. We provide the use case for KI Fogger to be tested, because we are interested in this to be working and to be introduced to the market. Thank you very much. Give him a big hand, Dr. Klaus Bauer. Klaus, please take a seat. Right, I think we could stop here, because I think you touched upon everything that is interested here. Klaus, I'm interested in one thing. 7 years ago, you started this. Did you know back then already if this will work out? We really need to get active? No, that happened later on. 7 years ago, we didn't even know whether our principle was going to work or not. But back then, when we decided to come up with a product, we knew that we had to protect it, because there's always the potential of it being misused. And with AI, another layer comes in. We created another layer. And I would say that AI, a couple of years ago, the AI discussion started, but we learned early what the potential is with AI. We have hacker groups in our company, in product development, in product security. We work with them together on what we still need to do. Can I ask a technical question, Mirko? You explained this beautifully. You are the bad guys, actually. You know how it works. Now, you came up with a solution, the steganographic techniques, the meaningless data. Now, who is faster, you or the hackers? Right. I deliberately did not use steganography, that word. It is the principle that is used. What does that mean? It means I have an information and I hide it behind a major information space. And only those who know the steganographic technique, who has the steganographic key, can put the information back into order and get the meaningful information. And that is the process that we apply. This has been around for a while, but for AI training, for this to be used for AI training, this hasn't existed for long. Now, we have a lot of experience on how to destroy things, how to train AI systems so that they do what we want them to do. So that knowledge on how to do that we can now use in order to protect the systems. And Klaus, thank you for saying that we as an industry, we know traditional IT security. Trumpf knows how to encrypt programs in their machines. There are systems that nobody can get into because of the keys and the encryption. But AI works differently. AI is something else. You can ask AI something and it gives you a reply immediately, and that cannot be encrypted in a standardized manner because I want the reply. So the attacking methods are also different. And with traditional IT security, I don't get very far here. But the question here is, would another type of AI be able to learn this method from the AI? Well, no. And that's the great thing. You take AI to extract the information. We live in a crazy world. I'm sorry. We take AI, we have AI, we take AI to extract the knowledge. That's the world we're living in, and what's so interesting about this method, the AI that is used by the attacker and that is trained is only learning from meaningless data, so it's not learning anything, and the attacker doesn't even realize this for a while because the training process is up and running. In the best case, it takes 7 months and not 7 years, and after 7 months, he realizes, oh, nothing, this is not really working, and then he starts training again, and very stupid attackers hopefully do this for 10 years so that the 7 years of Trumpf's 7 years are saved. Can you now sleep better, Klaus? No, not really. But that's not my motivation, because if I sleep well today, and the world will still change tomorrow, so this is not a process where we say that we come up with a solution and then the solution is ready, and then we can go back to sleeping well again. The methods behind that, the computer performances that we have, they are here. So we now need to come up with principles and with processes. And let me put it like this, I don't sleep well because this is so very exciting.
Right, Mirko. You together have developed solutions, and it's a consortium that works on this, and at some stage it'll make sense to establish a standard, something that is multipliable. Are you working on that already, or is it just for the consortium? Answer, well, in principle, we understand the methods and the tools, and now we want to use it properly. There are lots of questions that are interesting, one question being an economic one. So if you want to protect something, then of course you have to have some sort of effort involved. You need to carry on training the model so that it doesn't work anymore without the encryption. So you have to weigh off the economic effort, because if the model gets so big and you need such a lot of computing power to be prepared that even Trumpf would say, oh, well, there's not really any business case to be had with this, so this would be a sort of limiting factor. And then the other question is it technically safe? Because attackers are very creative. We are creative too. And the question always is, can you actually find the gap into the system? I told you that we use steganography and we use cryptography, and this is how you sort of lay your methods open, because then you have the opportunity that other people look at it, and if we say this is a safe method, we have the philosopher's stone, here it is, cryptographic community, hey, have a look. And they will probably say, okay, it's working. Or there will be people who say, oh, well, but in this particular space here, I have found a way in. So we want to make those ways transparent. We want to show how we do it, because once we have had proof by Trumpf, for instance, in this case, that it works, this is one thing. But there are lots of processes, the training processes, how do they work? How do you do the encryption management? And all this has an effect on the training lifecycle process with Trumpf itself. Yes, and just to add something, we initiated the project 3 months ago, and we have clear problems that we set and clear targets that we stated, and lots of great ideas as to how to approach it. But the project is going to be running for another 3 years, so we don't know everything yet. And just as Mirko said, on the one hand, we want to publish it for the reasons that have been mentioned already, and on the other hand, we do have a lot of societal responsibility. I mean, we're not the only ones in this position. Lots of others are in the same position. So we're interested to keep the situation fair. And finding results, of course, is something that you want to establish for other players too. Right, so let's, I mean, this is a general question that I always wonder about when it comes to AI. Let's go one step back. Software in the machine that needs to be updated all the time. Now, the trouble is now that you need to feed new training data into it all the time. How do you think this will work in the future? Say the training data in a machine should be updated. You still have the same protection system, or does the protection system also have to be updated? Answer, well, in the ideal world, you would have adjusted, qualified training data that you would carry on with your training. And we carry on with sort of noise interfered data. So we have a lot more data in the training process to generate this noise. So, for instance, you know, what the processor performance is and other topics that are addressed in the project, and that will have to be worked on. Klaus, another question to you. You had the idea that this could be done, and once you've been in production and you see a result, the colleague who has to do this manually is in a very difficult situation. But when you're thinking about the future, you want to deliver something that's innovative. Were you clear about the challenges that would present themselves in the future? Because this is even more in terms of innovation, isn't it? Answer, well, no, that's known. When it comes to software in the machine, it's no longer the case that the software is shipped and will remain in this particular way for 20 years. Because our machines are interconnected, because of the Cyber Resilience Act and others, we need to update the software all the time and provide added value to the customers all the time. So the modern machines are updatable, remotely updatable, just as you can update a car without having to go to the workshop. So these are mechanisms that will involve, and it's not only AI-based, but also standard-based modules, wherever it's necessary to have a look at product errors, to address AI cybersecurity aspects, or whatever. Yes, that was the contradiction in my mind, probably. We talked about the switching cabinet, protecting the switching cabinet. There's also manual access, but we were speaking about manual, remote access. Mirko, what about that? Because this could be a gateway, couldn't it? Let's say new training data was in the machine about remote access and so on. Answer, well, ideally, I mean, what you describe as man-in-the-middle attack, so the attacker would be between the communication of the machine and the manufacturer in order to be able to read this. And then the communication in between has to be encrypted very much so that the attacker can't read this, or it's also steganographic, which means that people can read the information. But imagine you have 80,000 pages of a novel, and you need to find the 5 pages that are really essential. And this is an additional protective measure. And now we need to look at what makes sense economically and technically for somebody like Trumpf. Yes, and all the things that you don't need to look out for that much. We have one question from the audience that we've already answered. You said that you're at the project stage, you started 3 months ago. What are the current steps? Because 3 months, that's not really that much for a company like Trumpf. You've defined the targets, I suppose, so you're not really in the practical aspect of things, are you? Well, 3 months ago, that was the official start of the project. It's a funded project, so we need to think of, putting together the consortium to have a common understanding, and that took a bit longer. The the application process, and you have to do quite a lot of preliminary work. So the status is not only 3 months since the consortium has been in place, but for the preparation, for the sketch, for the application, finding the right partners and organizing workshops, looking at the problems of the individual partners and finding out about the clear motivation of the partners. We're actually a bit further on than 3 months. Otherwise, we would be here today. In this context, that's another question from the audience. You've got lots of questions here, by the way, but I don't know who of the two of you would like to answer this question. How do quality and performance change in the models by the KI fogger? Answer, well, that's something that we're examining at the moment, because indeed the models, when it comes to the forecast, include a lot of nonsense, so the models get bigger, and the decisive question is how strong is the implication for the model. So this may have an impact on application proofs where the methodological approach to the model does not work. In Klaus's case, I'm not that worried. It hasn't got to do with real time, as we saw in the example. Somebody scanned the part, so you've got enough time to ask the model. You've got a certain degree of latency until the machine is ready in its programming. For autonomous driving, you'd need something else, because the latency here is relatively low. The model would have to be asked, what about the object there? Is that a pedestrian? Is it a tree? Is it another car? And this is where every millisecond plays a role. So it may be that we arrive at the decision that for latencies of a certain degree, it's a great protection, very usable, and in the safety relevant processes for autonomous robotics or driving, the method may not be suitable because the latencies are just too high. Maybe I can ask another technical question. I'd like to add something regarding the quality. Quality, of course, mustn't become poorer. We want to have maintained good quality, so it shouldn't get worse than it was. If we run into problems with the performance, then computing power is going to develop even further, and we have to accelerate processes. Either very specifically, or the machine will get a bigger GPU. Prices are developing drastically, so we don't always need to have the biggest machine with the highest power. There are always alternatives, and the systems that we had new on the market 2 years ago can also be used as add-on for such applications. And as machines will not only get cutting assistance systems, but will also get other things to work on things in real time, high performance. It doesn't always have to be deterministic. It's got to happen at the right point in time. So we won't get around adding to the control software. The control software we now have is probably enough for all the AI applications, or it isn't probably enough for the AI applications for the next 2-3 years. There are lots of things that are going to change. One question that I just thought of when looking at the combinations with other machines, with other tools. So Mirko has said you can even get the recipe for crystal meth if you want. So you've got the switching cabinet, you've got the remote method to access, you've got so many application cases for AI, you've seen them on the innovation stage, where the entire system is connected and AIs will talk to each other in the future. And this may just be intercepted. And then let's say that there's an ERP provider who says, well, we can optimize processes. And they will then want to talk to the machine and get the data from the machine. What about that? The protection would have to be rolled out to everything else that communicates with the machine. Answer, yes, exactly. I mean, the decisive question is not that you are not allowed to talk to AI. You should be able to talk to AI. It's got to be communicative. But whether it provides you with nonsense answers or correct answers depends on whether you're an authorized asker. And of course, another AI agent may be authorized. We're talking about this. We have an AI system here, and ideally in production there will be lots of AI systems that will talk to each other, but they need to be authorized, which means you've got the right key, and once this key is included, then the answers will be correct. So you've got to hand over the right key to the other AI, just as you would to a human being. Okay, Mirko, another question to you. Is there trained methods to, and that you can patent this technology? I think I'll hand over this question to Klaus, because Klaus needs to think about that. Well, when it comes to software itself, AI cannot be patented. There needs to be a method behind it. And this is specifically the idea. You can't have an algorithm patented, but the production method application, that can be patented. And the trick will be, how do I word it in such a way that I get this protection granted without revealing too much how you have implemented this. But that doesn't only work in AI applications, but in every technical system where you have to deal with software issues. Very good. Okay, I'd also be interested to know, Mirko, you said in your presentation what can happen. I mean, you're in the consortium together, there are other partners too, and you talk about practical experiences. Have there been cases where this case that have happened? Answer, yes. DeepSeek, we had one case with other generative use cases. These cases have been documented. The economic damage has been defined, and it's not a secret in industry that the ones that this was used unfairly actually were unfair themselves, which only goes to show much more that you need to think about protection. Let's say unfair practices become standard, then we will slip into a type of economy which makes it impossible for participants of AI to develop economic models and efficient models. And the interesting case is we have an enormous amount of dynamism regarding training. This is why I'm saying unfair practices. Everybody wants to ensure that their progress is their progress, but it's totally unclear as yet how the monetization is going to work. So that's a decisive turning point, let's say. And if we look at specific applications in the industry, in the economic assessment, you can probably cut a few figures of the investment, but you invested a lot, Klaus. And the question for you is the same one as the major applies of AI. what would happen if some AI provider would provide something that's even better. Speaking of competitors, you're not alone in your consortium. People all over the world are working on this. Trumpf has great competitors. What about them? You're market leader, but despite all that, your competitors will say, oh, well, we're going to do the same thing that Trumpf is doing. What about them? And what are they working on? Are there comparable consortia? What about the international scenario? Answer, well, I'm not really the right person to answer this in detail. I'll just make an assumption. I assume that all those who want to be market leaders are working on these issues, and that they look at where the ideas could come from. And of course, people copy each other when going through the halls here. You see many systems that look rather similar, but the question is it's, you know, the normal market rules that are applied, that's fine. Whoever invests can have some kind of return. But if you were to apply unfair practices, then things get difficult, but I can't really say who copied what from whom. And if you have these examples, as from Mirko, if people advertise that I have a comparable system that is even better and that I invested even less, then somebody should probably check it. Mirko, there are companies that won't say, like Klaus, we will think about precautionary measures from the start. And as you admitted, it wasn't an issue from the start for you too. But there are smaller plant engineers too who don't think in these dimensions. And what kind of advice would you give them if they haven't thought about protective mechanisms yet? Answer, well, AI in industry is a major topic. So on the one hand, we notice that it's got a lot of potential, and on the other hand, we know that there are obstacles in industry to really enter into this whole topic. It's got to do with knowledge. It's also got to do with anxiety and concerns. Do people lose their IP? And the basic advice would be not to be too cautious, because up until you come to the point where, like Trumpf, you think about how to protect something, a lot of time has elapsed. And a lot of sweat in the verbatim sense will be involved here. You worked so long and hard at this topic of artificial intelligence to enable yourself, and you've got to start at some point. And I would forecast if somebody started today as an SME and train his or her models, it will probably last, or it'll probably take longer than 24 months, and this will be a time where we would have the first results, where people would be able to start. So please do start straight away. Yes, and there are great organizations, the VDW, German Machine Tool Manufacturers Association, and there are groups who have a lot of experience, or the VDMA, the German Engineering Federation, which organizes information events. And then companies will report to those who want to listen. And it's not always somebody talking to you from up front, but there will be working groups in many cases where people will come together at a table, will discuss and organize things before they go into competition, because they all have some advantage to get. So I would recommend, if you're a small company, try to look for stakeholders in some of the associations. You will find a company that has already started. Let's go back to the consortium once again. Klaus, when will it have market maturity? The cutting assistant, or what I presented? Well, we're already equipping the first customers with this, with special measures and with some specific rules. And we have already taken measures that don't go as far as we think they should go yet. But if we don't approach the market now, the USP won't pay off for us. So once you have a 70% solution, you should probably go to the market. You should probably be optimistic and not let anxiety keep you down because it will hinder innovation. Yes, thank you. Well, what about the practical situation of your cooperation? It could be a blueprint for others to follow. You have a funded project by the government. How often do you meet? What do you talk about? What are the other partners doing? Because, Mirko, is this something, Mirko, that you work individually with the companies, or is there a working group where people who go in a different direction than Trumpf also participate and get involved? How does this work? Answer, well, we've got a sort of role distribution. Klaus is the one who's the guinea pig with Trumpf, and thank you very much for doing this. And this is really important because he has the actual model that needs to be protected, and then we've got different partners in the consortium. For instance, we are great when it comes to attacking AI systems. So if somebody comes to us and says, we've got a solution, we're very quick to check whether it was actually a great idea, a great solution, or is it only a partial solution to a problem? At the German Research Center for Artificial Intelligence, we also have a partner in that. We look at model integrity, the quality of training models. We look at the performance, and we've learned that this should not change if you ask the right questions. So these are the roles that the partners have. Or with Fraunhofer, we have a partner that knows how the entire data flow will work. Where are the data sourced? Where do the data go? How are they treated? How are they processed? How are they edited? How do they need to be enriched for them to be diluted? So there are very many different rules in this consortium. Then we meet in working groups or all partners together, and then we try to solve partial problems. Okay, and looking at the timeline in the consortium, Klaus, you said that the project will be going on for another 3 years. What are the interim milestones for us to wait for? So if we're at the next EMO, what can we look forward to? At the next EMO in next year, actually, I'm sure we'll be able to present qualified results. I'm absolutely convinced, because we are all interested in ensuring that what we have as a research project now, that we test it straight away in real life, to find out whether things need to be accelerated in some parts, whether some things may need to be given up. And already today, we have some questions that we've been able to answer, problems that we could solve. So in a year's time, on this stage, I'm sure we can share real experience. Let's talk about internal acceptance for a moment. Internal acceptance of these systems. Mirko, maybe you can tell us about this from the talks that you have from your customers. Klaus, first of all, artificial intelligence, is this a topic across the board where the executive board says, yes, go for it? Answer, yes, that's certainly the case. About 10 years ago, we started experimenting with artificial intelligence, and we drove this forward. We have a data AI topic that is active in the entire company. We have experts. We have an e-hub where the corporate IT defines AI processes, because our company said AI is a strategic element for the company and for the products of the company. And since January, we have had a position of head of AI, both for product development and for the processes surrounding it. That's important for the entire group. Mirko, let's leave Trumpf aside for a minute and talk about small and medium-sized enterprises, where I always think that AI is probably not so relevant. They probably a bit afraid, concerned to address this. But once you have these training data, it would probably be important for small and medium-sized businesses too. What you say to that? Answer, well, we have the advantage that when we look at our customers, we are usually at the top layer of industry. The adaptation of AI always depends on the executive boards and sort of trickles down. It's the executive board that sort of sets the pace, and then it all trickles down. And there's usually the right resources, such as innovation or positions that deal only with AI. That's the benefit of being a big organization. And there we also have the situation where people have recognized it's a game changer. It's not sort of AI, blah-de-blah presentation stuff, but it's actually a game changer. Like the internet was in the past, or fax or telephone. I mean, who still uses the conventional phones in their offices? We usually use internet for everything, and AI has a similar quality. Only in its introduction, it's much faster. Just think about ChatGPT. When did we start using that? 2 years ago? How does that change your personal life, your private life, and your business life? It's crazy. And if you don't recognize that, and if you only react, that's wrong. You need to act. And the big companies are great at acting. And if we go down in the food chain, apart from the startups, which are very agile, but in between there's usually a group of companies that have lots of different limitations, not only AI, but they usually have lots of fields of activity. And then as an executive board, if you address or want to address AI, or managing director, if he or she has to decide what to do about AI, it's really difficult if you have so many other things to think about. I understand that. You shouldn't always tell these people, well, you're too slow. Well, associations are really key here, like VDW or VDMA, that understand that communities need to be generated, so that the early adopters and the ones who do this need to be brought together with the ones who are enabling things and try to speed it all up. Because what's interesting is that even Trumpf is dependent on the machine tool manufacturer, and that's much smaller a company, only 100 employees. So if we don't manage to get linked up, you can be as good as you can in AI, but if you're dependent on somebody else and they don't, then you've got a problem. Right, unfortunately, we've run out of time. Mirko and Klaus, thank you so much for the insights. I'm really looking forward to the products, but I'm also looking forward to Mirko's solution, because at some time we'll see this across the board. Thanks so much. I wish you every success with your initiative. I think this is something that we can all benefit from. A big hand, please, for these two top speakers. Thank you.